Fala galera, boa tarde.
E aí,
Ah,
pessoal, tudo bem?
Estamos com um pequeno problema técnico, digamos que foi um desencontro aqui de time zones. O pessoal do Central Time, que é o time zone que o Uncle Bob está, entrou em horário de verão faz 2 semanas, algo assim. Então a gente já tinha combinado antes e acabou que a gente não considerou o CDT, não considerou com o time zone. Então a palestra do Uncle Bob, que estava programada para começar agora às 14 horas, ela vai começar às 15 horas, por causa desse desencontro. Então a gente vai manter o mesmo link, vai manter a live online aqui por esse período. Daí a gente queria contar com a paciência de vocês um pouquinho aí, que quando for umas 15 para as 3, aí a gente vai entrar online novamente. Nós temos dois links de transmissão. Um é esse link aqui, que vai ser a palestra em inglês. Nós vamos ter um outro link, que é a palestra com tradução simultânea. Então, para quem ainda não. Para quem não domina o inglês aí e quer acompanhar a palestra, não vai ter problema nenhum. E eu peço a, a compreensão de vocês aí. Acabou que é a primeira vez que a gente está organizando um evento internacional e a gente teve esse problema, esse desencontro, tá? Então, daqui a pouquinho a gente já vai estar online definitivamente. Eu e o Ivo, a gente está dando suporte aqui com o Uncle Bob, o Everton está dando suporte com o tradutor lá com o Ciro, então daqui a pouquinho vocês vão ter o conteúdo aí que a gente está esperando. E podem ficar. Estamos muito ansiosos por essa palestra e também estamos ansiosos pela Conf. Vamos ter bastante coisa aí para frente. Essa sexta e sábado vai ser bem movimentado aí, muitas palestras. Então, vamos manter online esse link aqui, vai ficar com aviso aqui por enquanto. Se puderem deixar aberto ou voltar daqui a pouquinho, vamos continuar com esse mesmo link, beleza? Então, obrigado, galera.
Até mais.
E aí, pessoal, vou fazer uma breve introdução em português e assim que começar, daí a gente vai mudar para o inglês. Nós temos um link específico que tem tradução simultânea, então para quem não é confortável com a língua inglesa, a gente vai ter uma tradução simultânea. E daqui a pouquinho aí a partir de agora a gente vai fazer essa introdução, vou fazer a introdução em português aqui, e assim que a gente colocar o Uncle Bob, a gente vai falar em inglês, beleza? Bom, a Conf vai começar hoje, dia 18, vai até dia 20 de novembro. Nós temos as perguntas dessa palestra podem ser enviadas no Slido, que é esse QR Code que a gente está mandando. A gente vai mandar o link também no chat. Então a gente vai fazer por lá, a gente vai trazer as perguntas para cá, tá? Então, por favor, mandem perguntas, a gente está aqui para falar, para trazer perguntas, e a gente tem esse espaço para estar perto dos nossos palestrantes. O evento também só é possível porque temos patrocinadores, temos pessoas que estão... temos empresas que estão interessadas em contribuir com a comunidade. Entre elas a gente tem a BevTech, Elotech, o iFood, Matera, TechnoSpeed, Trade Technology, a Turing e a VivaWeb. Nós vamos ter algumas novidades deles ali no speakout.group, que é a plataforma que a gente está usando. Então, vão ter alguns sorteios, algumas coisas aí que estão por vir. Por enquanto, a gente já tem algumas coisas ali, mas a gente vai ter mais coisas. Então, tem 10 vouchers do iFood, tem kit da Elotech com mochila, falando Bluetooth, tem alguns vouchers que a VivaWeb, para campus online, que a VivaWeb vai disponibilizar. Então, a gente vai ter isso daí que vai ser bacana. Lá vai ter vários sorteios, várias coisas, tá? Amanhã, sexta-feira, às 20 horas, a gente vai ter o talk show, que a gente vai bater um papo sobre o que está rolando e sobre a palestra de hoje também. Vai conversar aí sobre o que está acontecendo, né? Como a gente sempre faz, a gente vai o DC que vai puxar isso daí, vai ser um papo meio descontraído aí sobre o DevParaná. E nós vamos ter várias palestras, começando às 9 horas da manhã. Vamos ter 3 palestras simultâneas, então vocês vão poder escolher os links ali, o que vocês vão... Tem várias palestras ao mesmo tempo, pode dar uma olhada, vai ter tudo sob demanda depois no YouTube, depois que começar. Depois do almoço começa às 13h30, a gente vai ter um painel ali com a Kita e com o Bona também, que a gente entrou ontem, tem várias palestras bem interessantes na parte da tarde também, e fecha às 17 horas com o Otávio Santana e com a Karina Varela. E agora vamos trazer aqui ao palco o nosso convidado. Vou trazer o Ivo também, para ele nos ajudar nesse momento. Hi, Uncle Bob.
Hi.
Nice to have you here with us today. Sorry for this misunderstanding about the time zones. It was our fault about it. We didn't have to consider that.
Time zones, awful.
Yeah, we have this mistake a lot of times. Thank you for being here. It's a pleasure. It's an honor to us. It's the first time that we have someone that is an international speaker on our conference.
Oh my!
It's an honor to us to have someone with the background that you have here. And can you introduce yourself? I believe a lot of guys already know you, but if you can do that.
Yeah, sure. My name is Bob Martin. I have been a programmer since 1964. I was 12 years old at the time. My mother bought a little plastic computer for me. I have it here. Let me get it for you. Hold on.
Nice. Also, history in essence.
There you go. This is my little plastic computer that my mother got for me when I was 12 years old. It has 3 bits, 1, 0, 3 bits down there. Little flip-flops. And it's got these little rods here that are AND gates. They sense the positions of the flip-flops. And then on the back side, there are little metal rods that will push the flip-flops in one direction or the other. So in essence,
Oh.
it's a 3-bit finite state machine. You can program it by putting little tubes, little soda straw tubes on these pegs. So you can get it to count up and count down and add numbers and subtract and things like that. It just fascinated the heck out of me when I was 12 years old and put me on the course of being a programmer. I just, after that, I just started reading everything I could about computers. My father got me this book. I don't know how old I was. I was probably, I was probably 13 or 14.
Learn Boolean algebra.
Boolean algebra, right? With
been a while.
Pictures of gates and truth tables and Carnot maps and stuff like that. I just inhaled all this stuff at that age. He found me, my father was an interesting guy. He found me books on Fortran and PL1 and COBOL. I read all those things. I got my first job as a programmer at the age of 17 and never looked back. That was my career.
Yeah, nice to hear.
Yeah,
it's very nice. It's very nice to see that you still having your first programming time. And it's hard, as I understand.
Yes, I have a question. Sure. Tell us how was to program at that time. Let me see.
What was that question?
Tell us how was to program at that time. You said you started a long time ago, at least for my standards.
That machine was just putting little tubes on pegs. The next computer that I saw that I could actually touch was was it called an ECP-18, Educational Computer 18. I was about 14 years old. And my high school was going to buy this. They didn't in the end. They didn't buy it, but they were going to. It was a machine that was roughly the size of a librarian's desk. It had a nice little front panel on it with buttons that you could push. It had drum memory, no core, no solid state memory, drum memory, which meant that the clock rate was about 1 kilohertz or less. It could put 1024 words, 1K, on that drum. And you programmed it by toggling in the programs on the front panel. So you had to do it all in binary. Everything was in binary. And I sat there as, a very enthusiastic young computer person who had never touched a computer. And I watched the installers play with it. So they came in, they wheeled it in, and they started playing with it, and they checked it out to make sure it was working. And they would toggle in instructions into the computer, and under their breath, they would announce them. They would say, load 1426. And I could see that load was a 10. It was the opcode 10. So load. That's going to load something. And then he would say store, 4296. And the store was a 15. I saw that too. And bit by bit, I was able to infer the instruction set of this machine. And then he would go away. And without permission, of course, I went up to this machine and I started toggling in programs to see if I could get them to work, which I did. I got a few of them to work. They weren't great programs, like add 2 and 3 and get 5. But that was pretty exciting for me.
Oh, I bet it was.
So that was the next computer I touched. My high school eventually got a teletype link to a computer at the Illinois Institute of Technology. And that was a 10 character per second modem line teletype link. And we would program in a language called ITRAN, IITRAN, ITRAN, which was in Illinois Institute of Technology's language. They were executing it on a UNIVAC 1108, which was a huge machine. UNIVAC 1108 would have filled this room behind me to overflowing. You needed special air conditioners, and it was very, very fancy, multi-million-dollar machine. which, you know, my watch is more powerful than that UNIVAC 1108 now. But we would program it in Intran. We would write programs to solve the quadratic formula or calculate a bunch of Pythagorean triplets. Or, we did all kinds of things. And of course, I and my friends became the de facto operators. The math professors were supposed to be the operators, but we knew more about computers than they did. So we just kind of took it over, and they would ask us to do things. And we were very happy to, be the gods of that teletype.
Wow.
On weekends, my father, again, an interesting fellow, my father. On weekends, my father would drive me and my friends to the digital equipment sales office. This is the people who made early PDP-8s and PDP-11s, early mini computers. And in the sales office, they had a few machines. And he talked to the guys at the sales office and said, "You're going to allow my son and his friends to play on your machines," which they did. We'd go up there weekend after weekend after weekend, learn how to program a PDP-8, learn how to edit code on paper tape, how to write programs in a real assembler. That was my life. That was the first 5 years of my life. Was just completely immersed after about age 12, right? Completely immersed in this technology. Then, of course, I got a real job, and that was assembly language programming on mini computers. I did a little COBOL, but terrible. Mostly assembly language for the next, 10 years, probably just nothing but assembly language in various computers. I picked up this book, got it by accident. I keep it in a Ziploc bag now. This is my original. Picked it up in 1979, probably. All right. Kernahan and Ritchie, C Programming Language. I keep it in a Ziploc bag because I used to read it in my backyard. I had a little campfire circle out there. So I'd go out and I'd set a little campfire and I'd sit out in the evening and I'd read it. And it still smells like smoke. So I keep it in a Ziploc bag, right? And I read this book and I inhaled it. I absolutely inhaled this book. Up to this point, I had thought that high-level languages were a terrible mistake. No one should ever use a high-level language. They're slow, they're constraining. Whoever wants to use Pascal, Pascal would be terrible. And then I saw C. And I realized that C was an assembly language. It was just a slightly different syntax, but I could do all the shifts and all the rotates and the ands and the ors, and I could still play with bits. And so I became completely sold that this was the language of the future. It was the last programming language. There wouldn't be any others.
And continuing makes sense nowadays because we have a lot of usage about C and derivatives about that, other language derivatives about that nowadays. I have another question that is not related directly to software, to code, but is related. How was signed the Agile Manifesto?
Who signed it?
Question.
Who signed it? Did you ask me who signed it?
No. How it was to sign that? At that time you had the idea that make a lot of. How was that time? I have this question every time that I see. So, for me, you and other guys was making some barbecue and talking about software development and achieve that, but it's only my perspective about it.
It was a very interesting time. Kent Beckett already put out the Extreme Programming book. He and I were collaborating on teaching courses about extreme programming. Martin Fowler was involved. Ward Cunningham was involved. We were all kind of just hoping to get these ideas into the industry. And at some point, Martin Fowler and I sat down and decided to call a meeting. So we sent out this big email to a whole bunch of people. and said, yeah, let's meet in the Caribbean. We'll find an island in the Caribbean. We'll all meet down there. We'll have fun. We'll talk about this lightweight process stuff that we're all we're all interested in. Alistair Coburn called me up and said, I was just about to send the same email, but I like your invitation list better than mine. Is it okay if I add a few people to the list? And in return, I will organize everything in Salt Lake City. And we said, yeah, I mean, if you're going to do all the work, go right ahead. So he did all the work. He set it up at Snowbird in Salt Lake City. And 17 of us got there. There were a lot more people invited. I think the number must have been 30 or something. And we've often been criticized that there weren't any women at the meeting, that it was a bunch of, middle-aged white men. But we actually had invited some women and some other folks as well. It's just that it was those 17 who showed up. And I've been to a lot of things like this, a bunch of guys get together and we kind of shoot the conversation for a while, and we draw things on whiteboards, and then we go home and nothing ever happens. And that's not what happened here. Something happened here. It was very interesting. And it all started out the same way. We drew things on whiteboards, and we drew things on index cards, and we put them on the floor, and we sorted them, all the same stuff. And by the time the first day was over, I'm thinking, whatever, this is, not going to go anywhere. And then the second day, I think it was the second day. Sometimes I get this confused, but sometime on the second day, someone, and there's dispute about who this was. I think it was Ward Cunningham. A lot of other people think it was Martin Fowler, but someone went up to the whiteboard and they started to write the manifesto. They didn't write the complete manifesto. They wrote a couple of lines, but the key idea was that there were these ideas that we preferred above other ideas. Not that those other ideas were bad. It's just that we like these other ones a little better. And all of a sudden, the whole group went, oh, yeah. And we kind of wordsmithed it a little bit and came up with the manifesto that you've seen since. Then we had a little meeting about what to call it. I thought we should call it lightweight process, but nobody liked that idea. Jim Highsmith said we should call it adaptive. Nobody liked that idea. John Kern said we should call it agile because the military really likes agile stuff, and nobody liked that idea. And then we had a vote, and there was like one or two more votes for agile than anything else. And we all kind of went, all right, we'll call it agile, whatever. And we all decided to go home. And in the last minute, Ward Cunningham said, well, I'm going to put this on a website and I'm going to get people to sign it. Now, the year was 2001, and the idea of people signing websites was brand new. I mean, interacting with a website was brand new in 2001. People had been pulling data up on a website for a couple of years, but sending data in, that was kind of brand new. And Ward Cunningham said, yeah, I'll get people to sign it, which he did. He put up agilemanifesto.org, still there. And we all flew home, and I thought, okay, great, we're done, nothing else to do. Tens of thousands of people signed the damn thing. We didn't know that was going to happen. And that was really kind of the end of it. There was one other meeting about a year later. Not all of us were there. Some of us were there, and the guys said, we're done with this. We don't want to do anything more. We're not going to meet anymore. We don't really like each other that much anyway. So we all just kind of said, all right, fine, whatever. You get a bunch of very, very opinionated, very arrogant senior consultants in a room. And there's a lot of disagreement. So it's quite amazing that anything at all happened in that meeting. And yet it did. One of the few times I've ever seen anything like that.
Amazing story. Thank you for sharing this with us.
Sure.
Bob, I believe that we can start your speak right now. If you thank you for this time to just warm up the guys here.
Sure.
You will share your slides. How?
I think I can do that. Let's see.
Then I add on the stage here, and we left.
Screen 1. There it is. I can share it. Oh, let's see if this works. Yes. Okay, that should work. Ooh, yeah. Now let's see if I can do this trick that I just learned. And that trick is I can hit the play button, and then I can swap the screen, and oh heavens, I don't think that worked.
Didn't have work.
Don't worry,
No, that
don't
did not
worry.
work. No. Okay. Yeah, all these
We
video
allow
conferencing
mistakes.
tools are different. You know, it all works. So I'm going to leave it as it is. You see it here. Let me grow it. You devil. Let me grow it so that you don't see my email back there. Good. And I'm going to leave it like this, and I can deal with it this way.
Okay, I will add on the stage right now, and the stage yours. It's an honor to us to have this. Thank you.
Certainly.
All right.
And you're ready to go?
Yeah, ready.
Okay, ready to go. All right, so I welcome everybody. I hope you're all having a good day. We've just been having a lovely little chat about software things, you know, my history with software. I'm going to do a talk today. It's a talk that I have given many, many times in many, many places. In fact, I just got done giving it like an hour ago. So I'm going to do it again. I gave it to a bunch of guys in Bulgaria. So now I'm going to do it for you. The name of this talk is called Expecting Professionalism. And if my voice is a little rough, it's because I just got done giving this talk not too long ago. Let me make sure I turn off my notices so you don't see those, because you probably don't want to see the emails coming in. Good. Yeah. All right. There. So I got that done. Good. All right. Expecting professionalism. Here we go. Now, this talk begins by me transporting you into a world. I just got done clicking on the wrong screen. You know, I can see the video that you're seeing. So I'm looking at the video that you're seeing, and I'm clicking on it and wondering why the slides aren't behaving. Yeah, no, I got to click on the real screen over here. And you can't see it, but it's right over there. Okay, so I'm going to click on that. There we go. I'm going to transport you into a fantasy world in which I am your new CTO. Now, this is not something you would actually want, because you don't want me managing anything. I'm not an administrator. I'm not a business guy, right? I'm a programmer. I write code. That's what I want to do. One day they will find me with my nose stuck between the keys of my laptop with a half-written program on the screen. That's the way I want my life to be. But let's say that I was your new CTO, your new chief technical officer. What would I expect of you? Well, I would have certain expectations. And I'm going to describe those expectations to you now. But I want you to realize that you are going to hear them with two different ears. The one ear will be the ear of the user and the customer and the manager, the same ear, right? And everything I say, you are going to agree with. That ear is going to think, oh, yeah, of course. It's obvious. Then you will also hear with the ear of the programmer. And the programmer's ear is going to think that all of these things are insane, impossible, can't possibly happen. This is going, you will have this reaction, and be prepared. The essence of what I'm going to be talking about is professionalism. Do we have a profession? Well, in order to have a profession, there must be something that we profess. That's what a profession is. We profess something. And what is it that we ought to profess? We ought to profess a code of ethics, a set of standards, a group of disciplines. That's what we ought to be professing. But we don't have that. We don't have a code of ethics. We do not have a set of standards that we all live up to. We don't even have a group of disciplines that we agree upon. We do not have a profession at this time. We desperately need one. We need a profession. You and I, we programmers, we need a profession. And the reason we need a profession is because we are in a very dangerous situation. Our civilization depends on software. This did not used to be true. Even 20 years ago, it wasn't true. 30 years ago, it certainly wasn't true. But now, our civilization depends for its existence upon software. And you and I are the ones writing that software. Look around the room. How much software is running in the room that you are currently in? And just look in your pockets. Look in your pockets. Do you happen to have a smartphone? You know, I got a smartphone. Do you got a smartphone? How much software is running in that smartphone? How many processors are running in this smartphone? Or look at my Apple Watch. How much code is running in this Apple Watch? I've got in my pocket here, what have I got? I've got AirPods. How many processors are in these AirPods, right? Oh, heavens, there's at least 3. I mean, the case has a processor in it, and the two little earbuds do too. Here's my car keys. My car keys have got a processor in them. And then I'm, around the room, holy cow, I've got processors everywhere. And in places you would least expect them. There's a smoke alarm on the ceiling. There's a processor in that smoke alarm. There's a clock on the wall. There's a processor in that clock. Go up to the kitchen. Go to see the microwave oven, processor in that, or the regular oven, processor in there. How about the refrigerator? Yeah, there's a processor in there. What about the dishwasher? Yep, processor in the dishwasher. Go to the laundry room, washing machine. Yep, processor in there and in the dryer as well. What about the cars? Go out onto the road, look at the cars. How much code runs in a modern car? Would you be surprised to know that that's probably 100 million lines of code? And I'm not talking about a Tesla here. I'm just talking about a regular old car. There's 100 million lines of code in that car. Now, most of that code is sitting in the fancier features, the radio, the tape player, if you've got a tape player, a disc player, or whatever. Maybe you've got an entertainment center. Maybe you've got a GPS in there. A lot of code in there. But there is code in your car nowadays that sits between your foot and the brakes. There are if statements in there, if statements that decide whether or not it's going to activate the brakes, right? And wouldn't you like to know what those if statements say? Wouldn't you like to know how those if statements were tested? How many people have died because the code between your foot and the brake didn't work? That number is close to 100. and that's just one car company. If you add up all the car companies, it's probably well over 100. There are a number of people who have been killed outright because the brakes in their car failed for software reasons. You and I are killing people. Now, we didn't get into this business to kill people. We got into this business because we wrote an infinite loop that printed our name once. And we thought, oh, yes, I want to do that for the rest of my life. And now, of course, we're killing people. So our society depends on us for its existence. We are the ones who control the flow of information and the processing of information throughout our entire civilization. We are the people who control the life's blood of civilization. And that's why this is important. We better get our act together and become true professionals, because if we don't, the governments of the world will step in and make us do it, and that won't be good. In any case, here's what I expect. Oh, I did it again. I clicked on that thing. Here is what I expect. As your new CTO, I expect, are you ready for it? You ready? Got the two ears? You got the two ears, the customer and the programmer. Are you ready? I expect that we will not ship shit. Now that seems reasonable, doesn't it? That we shouldn't ship shit. But I imagine there's a few of you out there who will admit that upon occasion you have shipped shit. I certainly have over the course of my career in a few situations. On the other hand, it is entirely reasonable for customers and managers and users to expect that we will not ship them shit. Where did this come from? Where did the idea that we should ship bugs to people, where did that come from? Where did the idea come from that we could release a beta? You know, a beta, beta testing, right? The idea of beta testing 30 years ago was that you would select a very small, very trusted group of users, and you would let them use your software in a controlled environment so that they could tell you how much they liked it. That's what a beta test was supposed to be. Nowadays, we just ship the beta. Oh, it's a beta, guys. Don't worry about it. Oh, yeah, it'll probably crash. Yeah, it's going to have bugs. Don't worry. It's a beta. When did we ever get the idea that we should ship betas? When did we ever get the idea that it was okay to deploy bad code, malfunctioning code that has lots of defects in it? When did we get this idea? Do you keep track of your defects? Do you put your defects into some kind of bug tracking system? Something like Bugzilla or Jira or something like that. Do you put your defects in there? Do you keep a nice list of all the defects of your system? I want you to think about just how bad it is that we need an automated database system to keep track of all the defects in our systems. I mean, don't you think it would be better if we limited the amount of defects in our systems to maybe fit on an index card? Wouldn't that be a good thing? Oh yeah, there's a few defects, but there's not too many, just enough to fit on a card. Wouldn't that be nice? Why do we need a great big automated system so we can sort and collate all the defects? I don't think we ought to be shipping shit. I think we should be shipping good code. I think we should be shipping code that works. I expect, let's see, what did I click on? Oh, that was really cool. That's really cool. I've got my mouse on the right screen, but I can see the cursor on your screen. So I can actually move the mouse on the screen that you can see, and I can click on things. That's really weird. Okay, never mind. Sorry. I'm a geek. I get into it. So I expect that we will always be ready. What does that mean, always be ready? I presume that you're all doing agile stuff, right? Doing Scrum or extreme programming or FDD or one of the agile things. Maybe you're doing the less system or the more system or the reasoned system. There's a lot of adjectives that people have put in front of the word agile now. But all right, you're doing something agile. And that means, of course, that you're working in short time boxes. Scrum people call them sprints. Extreme programming people call them iterations. But whatever these time boxes are, and I assume that the length of your time box is 2 weeks. Okay, 2 weeks. Actually, I think it should be one. I prefer 1 week. I think too much can go wrong in 2 weeks. But most people use 2 weeks nowadays. Well, let's say it's 2 weeks. What should be ready every 2 weeks? At the end of every sprint, what is the state of the software? And the answer to that is the software should be deployable every 2 weeks. At the end of every sprint, the software should be deployable. From a technical point of view, not necessarily from a business point of view. The business may not wish to deploy the software because the software does not have enough features, but that's irrelevant. From a technical point of view, we are ready to deploy. We have done all the testing. We have done all the documentation. The system as written works. You may deploy it if you wish. Oh, business people out there, if you wish to deploy it, go ahead. You have our blessing. It works. Yes, I know there's no login yet. There's only log out, but log out works. If you want to deploy it with just log out, go for it. It works. That's the readiness that I'm talking about here. We will always be ready on a very regular basis to deploy. I want deployment to be a business decision, not a technical decision. I do not want the technical team stopping the business and telling the business that they cannot deploy because the system is unstable. Have any of you ever participated in stabilization sprints? This is when you're all done, you've got all the code checked in, everything, all the tests are working, and now you sit there and you just let the system run and you watch it for a month, wondering if it's going to be okay. And you don't deploy it to anybody. You just run it in some kind of special test environment and you watch it for a month, hoping that it'll still work. And you're looking for smoke coming out or crashes or something like that. And if it survives for a month, then you're ready to deploy it. I don't want any of that. Now, you should know that it works at the end of every sprint. You should know that it works. You should be able to deploy it. The business may not want to deploy it because it doesn't have enough features. That's fine. We are ready. If the business says deploy, we say fine. Go right ahead. This is weird. I can actually see where it is on the screen. I expect stable productivity. Stable productivity. This means that you will not be less productive a year from now than you are today. I expect the level of your productivity to remain stable. Now, here's the scenario. Let's say that we're a programming team and we've got a brand new project. There's no code, right? It's a green field project. There's no code. How fast can you go when there's no code, right? And someone asks us for a feature and we go, yes, we can do that feature. And code begins to pour out of every orifice of our body, writing code. And a week later, we've got that feature. And people stand at us and say, we've never seen people go that fast before. Heavens, can you do it again? Can you do another feature? Yes, we can. Come back to that team about a year later. Ask them to do one simple little thing. Ooh, that could be pretty tricky. I think it's going to take us 6 months. Like, you used to do that kind of thing in a week. Yeah, but you don't know how complicated this system has become, how tangled, how a mess it is inside. Why, if we touch even one line of code, all hell could break loose. No, it's going to take us months. That is unstable productivity. When the code degrades, when the systems get harder and harder to manipulate, when the risk of changing even one line of code skyrockets, that is unstable productivity. I do not expect that. I expect stable productivity. I expect you to be able to go just as fast a year from now as you went when you started. I do not expect the code to degrade. As a matter of fact, let's see if I can do this. I expect you to be able to change the code. I expect inexpensive adaptability. Inexpensive adaptability. Software is a compound word. It consists of two words, soft, which means flexible, and ware, which means product. Software, flexible product. The reason we invented software was so that we could have flexible products. We invented software because we wanted to be we wanted it to be easy to change the behavior of our machines. Had we not wanted it to be easy to change the behavior of our machines, we would have stayed with hardware. But no, we wanted it to be easy to change the behavior of our machines, and therefore we invented software. If you create a software system that is hard to change, you have thwarted the very reason that software exists. Software must be easy to change. That's inexpensive adaptability. The word inexpensive is important there. Customers understand that big changes will cost more than little changes. However, it's their interpretation of big and little that counts. Customers will look at a change and they will realize the scope of that change is large, and so they will understand if it costs a lot to make the change. Where customers get very upset is when they propose a change which they believe is simple, and all the programmers say, oh no, that thwarts our architecture. It completely ruins our design. Everything's going to have to change. It's going to take us years. And the customer doesn't understand that, because as far as the customer is concerned, this ought to be a simple change. The system should be adaptable based on the customer's view of what is complicated and what is not on your view, on the customer's view, which means that you must tailor the system to the expectations of the users. The adaptability of the system must be inexpensive. If you create an architecture which resists change, that architecture is bad. It's so weird that I'm looking at the wrong screen. I expect continuous improvement. What does that mean, continuous improvement? Well, it means exactly what it says. I expect continuous improvement. I expect everything to get better with time. The code should get better with time. The design should get better with time. The architecture should get better with time. That's what human beings do. That is the very nature of being human. We improve things with time. We do not allow them to degrade, at least not if you're a responsible human. That is the nature of humanity, is to make things better with time. Our code should improve. Our design should improve. Our architecture should improve. Everything should be getting better with time. There is a rule that I like to use. It's called the Boy Scout rule. The Boy Scouts had a rule. It was leave the campground cleaner than you found it, right? If you go camp in a campground, when you leave that campground, make sure it's even cleaner than when you entered, right? Now, I changed that. I call the Boy Scout rule this. When you check the code in, check it in cleaner than you checked it out. Every single time. Every single programmer. Every single time. Check it in cleaner than you checked it out. Imagine if we just did that. Just that. The system would get better and better and better with time. The designs would improve, the architecture would improve, the code would improve, everything would get better with time. And we would have inexpensive adaptability, and we would have stable productivity if we simply followed the Boy Scout rule. Before you check in the code, do one little act of kindness, some random act of kindness that makes the code just a little bit better. Doesn't have to be a lot better, just a little bit better. Check it in. Never make it worse. Check it in a little better than you checked it out. If everybody did that, I expect fearless competence. Fearless competence. What's the opposite of fearless competence? Fearful incompetence. I don't expect that. I don't want you to be fearfully incompetent. Let me explain that. You're sitting there looking at your monitor, your screen. You pull up some code. It's terrible code. It's awful. It's horrible code. The blood drains from your face. You go, oh no, not this code. And a little angel whispers in your ear, and the angel says, you should clean that code. You should clean it. But then the devil pops up on your other ear and says, don't you dare clean that code, because if you clean that code, you will break it. And if you break it, it will become yours forever. And so you back away. You don't clean the code. You're afraid of it. You don't want to own that code. You don't want to break that code. And so you allow it to remain in the messy situation. This is why code rots. This is why code goes bad with time, because no one will do what is necessary to prevent it from rotting. The one thing that would stop this would be the Boy Scout rule. Just clean it up a little bit. No one will do it because they're afraid. They're afraid. They react in fear. They don't want to be the ones who break it. And therefore, I want you to think about how wildly irresponsible that is. To be afraid of this thing that you created. You wrote this code and now you fear it. You were the master. You wrote that infinite loop that printed your name. You knew you were the god of code. And now that code masters you. Now you react to it. You have no control over it. It controls you because you fear it. How wildly unprofessional that is. So what do we do about this? We've got to deal with this fear issue somehow. Well, what if you had a little button? Maybe it's on your keyboard. And when you push that button, lights blink and computer sounds come out. And then within a few seconds, maybe a minute or two, a little green light lights up. And the green light says that everything works. The whole system works. What would you do with that button? If you had that button, you could push it and a little green light lit up and said everything worked. What would you do with that button? Imagine that bad code on your screen now. The horrible code, the blood drains from your face. Oh, God, it's horrible. And the little angel whispers in your ear, you should clean the code. And your next thought is, oh, I should change the name of that function. It's kind of the wrong name. I'll just change the name. Push the button. Green. Good. That function's a little long. Maybe I should split it in half. I'll just break it in half. Give the two new functions nice names. Push the button. Oh, still green. Good. Yeah, this function here that I just created, that really belongs in this class over here. I'm going to put it in that class over there. Push the button. Ooh, red. Turned red. Oh, heavens. Put it back. Put it back. Put it back. Push the button. Green. Green. Okay. Oh, I see what I did wrong. That function really belongs in this class over here. Push the button. Green. Good. If you had that button, you would not be afraid. If you had that button, you could clean the code. If you had that button, you would clean the code. If you had that button, the Boy Scout principle would be easy. The Boy Scout rule would be trivial. And you would have inexpensive adaptability, and you would have stable productivity, and you would probably not ship much shit if you had that button. So how do you get that button? Well, there's a discipline. The name of that discipline is test-driven development. I'm not going to describe it in any detail to you here. I can do that at another talk for another day, but just today, you can look it up on your own, test-driven development. But if you follow that discipline, test-driven development, you will create that button. That's what that discipline does. It creates that button for you. I'm not going to tell you it's easy, but it can be done. I've done it. Lots of other people have done it. And let me tell you, when you've got that button, it changes everything. It changes everything about writing code and maintaining systems and cleaning code because it takes away the fear. I'll leave you to look for that button. I'll leave you to look for that discipline because there's other things that we need to talk about today. I expect extreme quality What does that mean? Well, it means that the number of defects in your system do not fill this card. You don't have a lot of defects. You don't, in fact, it kind of means you don't have any defects. Well, maybe that's a little bit more to expect. Okay, are you going to have a defect from time to time? Well, maybe you'll have a defect from time to time. But I don't expect, big databases full of defects. Maybe one or two every once in a while, and every one of them is a failure, right? Oh, doggone it, we screwed up. But okay, I expect extreme quality. I expect everybody on the team to be rejecting the idea of defects and bugs. I don't expect anybody to expect defects. I do not want you to expect defect. When did we do this? When did we start doing this thing where we say, well, of course it's going to have bugs. We're software developers. It's what we do. No, it's not. We don't do that. We build code that works. I expect that we will not dump on QA. This dumping on QA, that's when you write a bunch of code and you've got a schedule and you need to finish by a certain date. And so you check it in on the date and you hand it off to QA and it's full of bugs. But it's QA's job to find those bugs. That's a really sick situation, by the way, when you do that. And I should tell you, QA doesn't mind that, because if you give bugs to QA can report that they found a bunch of bugs, and that's how they get raises. Look at all the bugs we found. We're really doing our job great. We do not want bugs to have a positive value to anyone. We do not want QA desiring bugs. And we do not want programmers desiring the ability to leave bugs in for the purpose of meeting schedules. I don't want anybody dumping on QA. In fact, I don't want QA at the end of the process. QA shouldn't be sitting there at the end. QA should be moved to the beginning of the process. QA should be a specification role. What I want QA doing, I want them to find nothing. At the very end, they should find no defects. I want QA at the beginning of the process, specifying the system in terms of automated tests. I want automated tests written by QA, written by the business analysts, written by the business. I want them writing tests, not in code, in some kind of specification language, a formal specification language, but not code, no if statements, no while loops, nothing like that. Just a statement of here are the inputs and here are the expected outputs. Nothing difficult. The hands that you see on this slide are the hands of a QA manager. The QA manager is holding out a document for me to take a picture of. The year is 2008. Remember the financial crisis of 2008? Yeah. So this QA manager is holding out this document. This document is the table of contents for his manual test plan. It is not the manual test plan itself. It is just the table of contents. He has 80,000 manual tests that he must run every 6 months. He sends them off to an army of people in India to run them. It costs him $1 million. The year is 2008. The financial crisis has begun. His boss has just come back from the CFO's office, the Chief Financial Officer's office, where he learned that his budget is being cut by 50%. This QA manager has just learned that his budget is being cut by 50%. He's holding this out to me, asking me which half of these tests he shouldn't run. And I told him, well, you can cut the document vertically, horizontally, or depth-wise. It doesn't matter. You're not going to know if half your system works. This is the ultimate result of manual testing. Manual testing always leads to the loss of tests, because eventually they become too expensive. They either become too expensive in money, as in this case, or they become too expensive in time. And the QA people who are responsible for running the tests will not take the time to run them all. Manual testing is insane and it is immoral. Testing should be automated. You and I are programmers. For God's sake, that's what we do. We automate things. We shouldn't tolerate a bunch of people out there banging on the system, right? We should have everything automated, all the testing automated, so that no people have to be sitting there banging on the system. That's a terrible use of a human brain, and it leads to the tests being lost. You and I automate things. And don't tell me that that's expensive, because the real expense is having human beings, sitting there banging on terminals. It's a lot cheaper to automate the tests, guys. Automate your tests. Does that mean that there are no manual tests at all? Oh, I think there are some. I think there are manual tests. I do some manual testing of the systems I do, but typically those are either eyeball tests. I'm looking at, like, does the font look good? Does the color scheme look good? Are the windows arranged properly? That kind of thing, which really does take kind of an eyeball, right? Certainly none of the business rules are tested manually. That's just ridiculous. I expect nothing fragile, nothing in the system that tends to break a lot, nothing in the system that's constantly needing to be changed. I don't expect any of those dirty modules that are always causing the problem. Nothing should be fragile in the system. I expect that we will cover for each other. And by that, I mean this. We often talk about software teams. What does it mean to be on a team? Well, imagine a team of players moving the ball down the field. They're kicking or passing or whatever, moving the ball down the field, and one of those players trips and falls. There's no flag on the play. The referees don't stop the game. The players continue. And what do? They change their field positions to cover the hole and keep the ball moving down the field. That's what I mean by covering. That's what a team does. Are you in a software team? If you are in a software team, then you must be able to cover for each other. If Bob goes down, he gets sick, he can't come in for a week, Bob's work does not stop. Other people can cover for Bob. If Bob is the guy who takes care of the database, the work on the database can continue because other people know how to work on the database. How can we do that? Well, I like to use a particular discipline. That discipline is called pair programming. I like programmers to work together at the same screen, at the same keyboard, not 100% of the time, enough of the time so that they can learn to cover for each other. I want Bob to work with Bill, so if Bob goes down, Bill knows what to do. I want Bill to work with Gene, so that if Bill goes down, Gene knows what to do. And in fact, I consider it your responsibility to make sure that someone can cover for you if you go down. That's how a team behaves. Let's see, where am I here? Oh, yeah. I expect honest estimates. Does that word fill you with fear? Estimates? It shouldn't. I want the estimates to be honest. The most honest estimate is, I don't know. Now, that's not a useful estimate. So in order to make that estimate useful, you must describe the bounds of what you don't know. And I like to do that using a simple technique. When someone asks me how long something will take, I give them 3 answers. The best case, the expected case, the worst case. Someone says, okay, how long is it going to take you to do this thing? And I say, well, if everything goes right, probably I can get it done in about 5 days. If things go as they usually do, it's going to take me more like 10 days. And if things go really haywire, like they sometimes do, it's going to take me 30 days. That's the estimate. I don't want to give them any more precise estimate than that because I don't have the precision, right? It's an accurate estimate because probably it's going to happen sometime in the next 30 days, right? So that's accurate. It's just not very precise. And the precision is the problem. As time goes by, I can make it more precise. Come to me in a week and I'll tell you, oh yeah, I'm probably going to get it done in the next 3 days. But I can't tell you that now. You should be giving estimates of that kind, whether it's 3 numbers or 2 numbers or some other kind of range. Maybe you just say, well, sometime in the next 30 days. Whatever it is, make sure it is a range that defines what you don't know. It defines your uncertainty. What you must not do is give a precise date, unless you are absolutely certain you can make that precise date. Otherwise, that's not fair. You need to specify the range that you expect the completion to fall in. And of course, managers aren't going to like that. They're going to say, well, you got to give me a date. And you should say, well, no, I don't have to give you a date. Because I can't give you a date. I can give you a range of dates. Now, you might think, well, no manager is going to accept that. Let me tell you what happens in the sales meeting, right? When the CEO calls all the salesmen in, right, and says, okay, how much you got to sell this quarter? You think they give them an actual number? The sales guys are going, well, somewhere between 1 million and 6 million. Depends on if this customer and that customer comes through and blah, 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 blah. They're doing the same thing, right? And by the way, that's the role of management. Management's role is to deal with uncertainty. If things were certain, there would be nothing to manage, right? So it's the job of managers to deal with uncertainty. Your role as an engineer is to properly define that uncertainty. So, honest estimates describe your uncertainty. I expect you to say no. There are times when a manager will come to you and say, I need this by Friday. And you realize that there is no way that it's going to be done by Friday. You've got to say no. You've got to say, no, can't be done by Friday. You need to find something else because you need to find a better solution because that's not going to happen by Friday. And of course, you're going to get confronted and the manager's going to get upset. Well, you've got to get it done by Friday. Well, I can't get it done by Friday. It's not going to happen. You see, you were hired for your ability to say no. Maybe you didn't understand that. Maybe you thought that you were hired to write code. And yes, of course, you were hired to write code. But more importantly, you were hired for your ability to say no. Because no is one of the ways you're going to save your company an immense amount of money. If you say yes when you know the answer is no, then the company is going to lose a lot of money because of broken promises. It's really important to say no when the answer is no. And then watch out for this, because there are managers out there that will attempt to manipulate you. And they will say something to you like, well, will you at least try? And the answer to that, perhaps surprisingly, is no. Because I'm already trying. How dare you accuse me of not trying right now? You probably don't want to say it that way. But that's what should be in your head, right? How dare you accuse me of not trying? What do you think I've been doing all this time? We have been trying. We've all been trying. The answer to your question is no. And don't ask me to try. The temptation is going to be to say, well, yes, of course I'll try. You've got to understand that when you say that, you are lying. because you don't have a plan. You don't have, you're not going to change your behavior. The fact that you said you'd try changes nothing. The answer is still no. You just said, well, I'll try. And the reason you said, oh, well, I'll try, the reason you said that is to stop the conversation because you didn't like the conversation. And that's irresponsible. It's unprofessional. It's irresponsible. I expect continuous aggressive learning. Keep on learning, keep on reading. Our industry is a strange industry. There's new stuff happening all the time, and you've got to stay ahead of it. There's new languages, there's new frameworks, there's new products, there's just new stuff all the time. You've got to stay ahead of it by reading like crazy. And by the way, the best way to learn something is to teach it. Take it from me. The best way to learn something is to teach it. So if you want to learn, if you want to do continuous aggressive learning, learn something and then teach it to somebody else. Teach it to someone who is junior. Take a junior aside and say, look, I learned this thing here. Let me tell you how this works. Learn test-driven development, then teach a junior. Learn pair programming, then teach a junior. Learn refactoring, then teach a junior. Learn a new language like Clojure, then teach a junior. Teach and learn constantly. And with that, I will close this talk. Thank you all for your attention. I hope you enjoyed this. I hope you learned a few things. And if there are any questions you would like me to answer, I'm perfectly happy to listen. And gee, I might even have an answer. It's possible, I suppose.
Hi, Bob. We have some questions. Eve, please can you join the stage and share the questions with Bob?
Sorry, Fernando, I didn't understand.
Can you join? Can you join and share the questions?
Yes, I will add a banner with the questions. Okay.
Oh, okay. Mm-hmm.
You can go on, please.
As software developers, what should I do to attain the expectations you mentioned?
Well, as a software developer, what you should be concerned about is standards, ethics, and disciplines. What are these things? What are these standards? What are the ethics? What are the disciplines that you need to have? I just got done writing a book about this, as a matter of fact. Here it is. This is the English version. It's going to be coming out in lots of different languages later. It's called Clean Craftsmanship, in which I go through the standards and the disciplines and the ethics of software development. Those are things that you should be getting into your head. The expectations that I set forth here, those things should be in your head. You should not be shipping shit. You should always be ready. Things like that. What should you do? Well, there's many things that you can do to help this. I mean, read a lot, of course. Read all kinds of things. Read software journals, read technical, read blogs, read as much as you can about software. Read other people's code. Learn how to read people's code. It's a very powerful technique. Learn how to write, not code. Learn how to write your own language, your native language. Learn how to organize your thoughts. Learn how to write a paper. Learn how to write a story. Learn how to write an argument. A programmer has to be able to communicate with other people. So learn how to communicate in the written language. Also, learn how to speak. Learn how to debate. Learn how to give a talk. You might want to do this at your company. Maybe at lunchtime, you can get everybody together and give them a little talk about something you just learned. Learn how to organize your speech, how to enunciate words carefully, and how to say sentences in the right order. Learn how to do these things, and it will make you a much more effective software engineer.
Nice, thank you. Can you share the next? Do you have any tip for a developer starting his career today?
Tips for a developer starting their career today. Read old things. Go back.
Read Uncle Bob. Read Uncle Bob books.
No, not my books. Go back before my books. Go get books that were written 40 years ago or 50 years ago. Read those books. The good ideas that those guys had in the 1960s and the 1970s are actually still very relevant today, and they are not well known. Those are go find books like this. Here, let me pull a couple of them down for you. Okay, so structured programming, written by Dijkstra, Dahl, and Hoare. Who were these guys, right? Dijkstra is the guy who invented the notion that GoTo might not be such a good idea. Who's Dahl? Dahl is one of the two guys who invented object-oriented programming. Who's Tony Hoare? Tony Hoare, holy cow, he's this guy that invented all kinds of algorithmic stuff. And here's a thin little book, Structured Programming. It's just full of gold, full of gold. Find this book. It's out of print. Get it on eBay. Find it somewhere. Get this book. Read this book. Here's another one. Let's see if I can get it for you. There we go. Fundamental Algorithms by Donald Knuth. Wonderful book. Wonderful. With loads of very, very good ideas in it. He's actually got several books in this series. Find these books. Get old books. Maybe you can find translations for these old books. Read these old books. Here's a little secret. Software has changed very little since 1945. Very little. The hardware has gone through a crazy evolution. The hardware has gone nuts. Software has changed very little. It's still if statements, while loops, and sequential statements. That's pretty much it. If I took a programmer from 1968, somebody who was programming this machine, see that machine up there on the wall? That's a PDP-8. Somebody who was programming that machine. And I brought them forward in time, and I put them in front of my laptop, and I showed them Java or Ruby or a modern language, and I showed them the tools, the IDEs, and the refactoring stuff they can do. If I showed them all of that, they would need 24 hours to recover from the shock. But then they could write the code because the code's not that different. I could show them Java and they go, oh, yeah, okay, if statements, while loops. Little classes. Yeah, that's what that guy did in 1966, right? Those two guys in Norway, they invented Simula. Yeah. It wouldn't be that different. They could write the code. They would get smart on writing the code within days. I could take you and I could transport you back in time and sit you in front of one of those PDP-8s and show you how to edit programs on paper tape at 10 characters a second. And you might need 24 hours to recover from the disappointment, but you could write the code. So the code hasn't changed that much. Software is not an evolving technique. There have been a few things that we've learned over the last 70 years. Most of those things that we've learned are what not to do, not new capabilities, but things that we were able to do and decided not to. Like we don't want to use GoTo anymore. Bad idea. We don't want to use pointers to functions anymore. Bad idea. And we are on the verge of deciding that we don't want to use assignment statements anymore. That's called functional programming, by the way. Everybody's interested in functional programming. That's when you don't use assignment statements anymore. We're learning what not to do, but there's no new capabilities. So you're a new person coming into this field. Do not think that you are coming in at the peak of this industry, right? There's a tremendous amount of knowledge behind you that you probably want to take advantage of.
You have talked about functional programming. We have a question here.
Sure.
This is right here. From Eduard, that is, what helped you switching between OOP thinking, functional programming, closure thinking?
It was not a switch. Don't make that mistake. Many people have said that, well, object-oriented programming and functional programming are completely different. And if you think in an object-oriented way, you cannot think in a functional way. No, that's wrong. You can think in an object-oriented way and a functional way. And you should. It's not a switch. It is a shift in attitude. In most object-oriented languages, there are lots of assignment statements. The objects themselves are mutable. You change their internal state by calling setters or other functions that manipulate their state. And if you're doing it in a functional way, you still have classes, you still have objects, you still have all of that, but the objects are not mutable. When you call a function on an object that changes its state, you actually create a new object and leave the old object behind. And there are lots of facilities that make that efficient. Don't get hung up on that issue. So don't think of it as a switch. There are some things to learn. They're actually not hard to learn. If you've ever written a shell script with pipes, so you got the filters and pipes, a Unix shell, and it pipes it into something else, and it pipes it into something else, pipe it into something else. That is a functional program. There are no assignment statements within that pipe stream. You probably know how to do this already. You just need to kind of get used to the idea that you're not going to be changing the state of any variables.
I don't know how it's your time. We have two questions here. If we don't assume the time, we'll stay forever here. Answering questions, but we have one here. Then I have other one. Ruben from Ruben Luz. Ruben will be a speaker on Saturday on our conference too, and his question is: will AI and automation take our programming jobs?
Yeah.
No.
Also, just a second. There is also another question that just came out here, and I think it follows the same meaning. How do you see the low-code and no-code scenario for software developers? So tell us about the future of programming.
So first of all, let's do the AI, deep learning, machine learning, AI, all that stuff. Is that going to get rid of programmers? For 70 years, people have been trying to get rid of programmers. And the only thing that's happened is that the number of programmers has exploded in the world. There are now, 100 million programmers in the world. So, no, AI is not going to get rid of this. And there's a fundamental reason why, right? Programming requires intelligence. And artificial intelligence is not intelligence. It's machine intelligence, which is fine. Nothing wrong with that. What we're going to discover is that our tools are going to get better. Our IDEs, the IDEs have just gotten so spectacularly good just in the last 20 years. It's kind of mind-boggling. And that is going to continue. As we get better and better at AI and machine learning, the IDEs will keep on suggesting better ideas and giving us better capabilities. But someone has to manage all those capabilities. Someone has to make the decisions. And that's a programmer. Understand who you are. You are a detail manager. You, programmer, manage all the horrible details that nobody else wants to deal with. You do that. You do that with if statements, and you do that with while loops. You manipulate things at the lowest possible level. There's no way machine learning is going to solve that problem, because that requires human creativity, human intuition, and human intelligence. Our machine learning may get very good. It may be a wonderful tool to help us. It will never supplant us. It cannot do that. The human brain is immensely complicated, far more complicated than even the entire internet. One human brain is more complicated than the entire internet. There is no way we're going to approach that. Not, at least not with today's technologies. And don't talk to me about quantum stuff. That's not going to happen either. Not the way people like to hype it up. That's going to be a different thing. The low code, no code thing, that's also an interesting one. And you should not fear it. Again, people have been trying to do the low code, no code solution for 70 years. It's a very, very old idea. It used to go by names like domain-specific languages and things like that, but went by the name of model-driven architecture for a while. Everybody wants to get rid of programmers because we're so annoying, and then they can't get rid of us. So the problem with the low-code, no-code stuff is that it must assume, the assumptions made constrain what the users can do. And then eventually, and it happens every time, the users will want to do something that you cannot do in the low-code environment. And you have to go into real code. You just, there's no way around it. You're going to have to dive into real code. So the low-code, no-code environment can be a tool that helps a programmer, but you're going to always have to keep those coding skills. Those coding skills will always be there.
Nice. Ivo, we have more 2 questions on.
That's fine.
On Slido. Sure. Then we can finish that.
Okay, 2 more questions, right? Then we settle down.
Okay.
Perfect.
How QAs and developers should work together? You said the QA process must come from at the beginning, but how does it work?
So I want QA at the start of the process. I want QA writing tests, specifying the behavior of the system by writing tests. Those tests can be in a specification language. Those languages are typically spreadsheet-like languages. You specify inputs, you specify expected outputs. That's where I want QA. I want QA doing that, specifying how the system works by creating automated tests. Programmers run those tests. Programmers know that they are done when those tests pass. That's the fundamental agreement between QA and programmers. QA specifies with tests, programmers write code that make those tests pass. That is the contract that I want to see between QA and programmers.
Nice. And the last one, do you believe Mandarin 3.0 will change the way that software is built?
I think you're talking about that book that was written by, what's his name? I can't think of his name at the moment. I wrote the foreword for the book. I'll think of it in a minute. Anyway, yeah, Management 3.0. No, I don't think that's going to change. Jürgen Apollo. That's his name. Jürgen Apollo. Yeah, I don't think that's going to change the way software is built, at least not at the low level. What I hope is that software is built using the agile techniques that started software in the first place, were lost from about 1970 until 1999, and then came back in the Agile Manifesto. That's the way I hope software is built, and continues to be built that way. Management is another thing entirely. That's budgets and schedules and uncertainty. That's a whole different matter.
Okay. Thank you for all, Bob. It was an honor to have you here with us, sharing a lot of knowledge. Some guys have asked how you have time to do all this stuff that you are talking about, because it's a lot of to go about this. And we really appreciate your time to be with us, sharing knowledge. It was an honor to receive our talk today.
My
Thank
pleasure.
you for that.
My pleasure. Sure. See you guys later.
See ya. Thank you. Bye-bye.
Bye-bye.
É isso aí, pessoal. Fechamos então o primeiro dia aqui. do DevParaná, agradecemos todo mundo aí, e foi um prazer enorme receber o Uncle Bob, e finalizando esse evento aqui, a gente queria agradecer novamente aos nossos patrocinadores. Temos 8 patrocinadores esse ano, então tem uma galera aí. E não percam, amanhã tem o DevParaná Talk Show às 20 horas. No sábado começamos às 9 da manhã até às 6 da tarde. Vai ter muito conteúdo bom. Fica atento porque tem 3 palestras rolando ao mesmo tempo durante alguns períodos do dia, então você pode escolher o que você vai ver ali. Às vezes tem alguma palestra que pode chamar mais atenção ou não, e isso daí é algo que você pode escolher lá. Vai ter muito conteúdo bom amanhã. Então, não perca a oportunidade de participar. Vão ter vários sorteios também. A gente vai estar falando amanhã, não, no sábado, né? Que a gente vai estar falando no sábado lá. Então, fica atento que no sábado a gente vai ter um monte de surpresa para vocês aí. Muito obrigado pela participação de vocês e até amanhã no Talk Show e até sábado de manhã na Conf, efetivamente. Valeu, galera.